Thank you all for standing by and welcome to our webinar entitled Spatial Ecology of Smallmouth Bass in Lake Erie. This webinar series called Freshwater Science will highlight Ohio's Sea Grant and partnering scientists every month. Every quarter is a different focus, from human health and fish farming to harmful algal blooms and human decision making, bringing applied research to the public on issues that affect our Lake Erie communities. I am Jill Gentis-Banicki from Ohio Sea Grant and Stone Laboratory, and joining me today is Zach Slagle from the Ohio Department of Natural Resources Division of Wildlife. Zach is a fisheries biologist from the Division of Wildlife stationed at the Sandusky Fisheries Research Station. He received his master's degree from the University of Florida in 2014 for research on Florida's smallmouth bass spawning success. Zach now leads the Division of Wildlife's trawl and smallmouth bass surveys in the Western Basin of Lake Erie and has worked for the Division of Wildlife since 2018. We're sorry about that. We're delighted to have Zach here today to talk about his Sea Grant funded fish research. Before we do, just a few things about the logistics of the webinar. During our presentation, all participants will be in a listen-only mode. Afterwards, around 12:20, I will conduct a question and answer session. If you would like to ask a question during the presentation, please feel free to pull up that chat feature at the bottom of your screen anytime during Zach's talk, and I will collect and pose your questions out to Zach at the end of his presentation. As a reminder, this webinar has auto captioning and is being recorded to be posted onto our website for later viewing. Also, we will post a webinar survey in the chat feature toward the end of the half an hour. If you'd like, please take a few minutes after the webinar to fill out that survey. It always helps us bring you great webinars. So without any further delay, I'd like to introduce Zach Slagle, presenting Spatial Ecology of Smallmouth Bass in Lake Erie. Zach.
Thanks a lot, Jill. And thank you to everyone who's out there online. I really appreciate your attention. So yeah, we're going to talk a little bit about smallmouth bass movement in Lake Erie. So I've structured this talk in a pretty standard format. We're going to get into the background of Lake Erie bass fishing and also a little bit of the theory that went into the design of this project. We'll get into some of the methods that we use to track bass across Great Lake. Then we'll look at the movements that everyone wants to see and finish up with some management implications and discussion. So for the background of this project, first off, we're talking about smallmouth bass. This is one of North America's great freshwater sport fish, popular across North America and the world. They fight very hard. They're a lot of fun to catch. In general, they're considered to be fairly low movement species, non-migratory, living most of their lives within a relatively small area. They're also, during the reproduction, they're nest garters, which is important because they, during that time, they readily strike on lures and they're very vulnerable to fishing. So if we look at the history of Lake Erie smallmouth bass fishing, a scene like this used to be pretty common back, 30, 40, 50 years ago, where anglers would go out and harvest a big stringer of bass and bring them home for a fish fry. But in the last 30 years or so, Lake Erie and really anglers across North America have embraced a voluntary catch and release ethic, where instead of harvesting illegal fish, they choose to release it, with the thought being that they're helping out with the continuing the population on. Another popular thing that's really increased in popularity in the last 30 to 40 years is bass tournaments. So these are competitive functions where anywhere from 6 up to 100 or 150 boats will meet at one specific location typically. They'll launch out for the day or a couple days, go and catch bass, and then return to their capture locations for a weigh-in. So they're trying to keep these fish alive, but then they're releasing them. They're actually transporting them potentially long distances and then releasing them at that weigh-in location. When we go and think about Lake Erie, so Lake Erie is one of the world's largest lakes. We've got Ohio waters of Lake Erie take up the second largest portion of the jurisdiction on Lake Erie. So we're looking at everything from Conneaut to the east to Western Basin, Toledo, and Sandusky down here. The Western Basin and the Central Basin are fairly different as far as bass habitat is concerned. Bass typically like rocks, reefs, fairly shallow water. So the Western Basin has these islands. We have the Bass Islands here. We've got Kelly's Island here. And there's a number of rocky areas and reefs scattered through the western part of the lake. Whereas the Central Basin tends to have fewer reefs. There are some reefs, but they're pretty near shore. There's no islands. There's not a lot of bass habitat over in the Central Basin. And as you can see, the scale we're talking about is pretty large. We have anglers can fish a wide area of the lake if they're fishing in a tournament. So I want to switch directions a little bit and talk about personalities in fish, which may not seem very scientific, but it actually is. There's some interesting studies that have been done in Illinois by Steve Cook, Dave Phillip, and company, where they worked on largemouth bass personality. So they started with this lake here that has a healthy population of largemouth bass. They then went and fished it fairly heavily, and of course they catch some of these largemouth bass, and then they would mark them and then return them to the lake. Eventually, after they did this for a few years, they end up catching some of these fish numerous times and some fish never at all. They then drained that pond and stocked some of these fish that were caught 3 or more times into a new pond, and then stocked other fish that had never been caught into a different pond. And they ended up raising these 2 different populations that can be considered high vulnerability fish, the ones that were caught 3 or more times, and low vulnerability fish. So they already learned one thing here, and that's that vulnerability to angling is a heritable trait that can be genetically passed down to their offspring. They then use these populations to study other aspects of them, and they learned a few different interesting things. So not only are these high vulnerability fish easier to catch, but they're better at guarding their nests. They're better at raising their young to a swim up fry stage. And they also have higher metabolisms. So there's a suite of physiological traits that are associated with high vulnerability angling. Likewise, the low vulnerability fish had kind of the opposite effect, where they're not as aggressive at guarding nests, they're not as good at raising their young, and they have lower metabolisms. However, they didn't study movement of these fish. And why do we care about movement? I have anglers ask me all the time, where are the fish going, that kind of thing. That's not necessarily a scientific question, but there are interesting management implications for us to think about. So in a low movement scenario, this is kind of the overriding idea where scientists and anglers generally believe that smallmouth bass don't move very much throughout their lifespan. So they might stick to a 5 square mile area of lake or something like that. Now, if this is the case, there's a couple of different implications for management. So if you have anglers hitting high profile areas or very popular areas hard, like the Bass Islands here, we might have some localized overfishing because there's no fish moving in to replace the fish that either get harvested or suffer from catch and release mortality. We also might have lower genetic connections, which on the high end of things might create a subpopulation or even a subspecies of bass because you don't have bass traveling back and forth between these areas. And then if you think about that like a normal tournament setting, if anglers are going out catching fish and then transporting them, in some cases 15 miles or 24 kilometers or more, those fish might not be able to make it back to those original capture locations, and they might be functionally harvested, even if we are keeping them alive and releasing. On the other hand, if we have fish that can make some long distance movements, they can repopulate areas that have localized overfishing. They could genetically connect subpopulations, and if they were displaced in a tournament setting, we might see those fish return to their original capture locations. So I'm not the first one in the Division of Wildlife to ask these kind of questions. My predecessors in the late 90s and early 2000s undertook a movement study using jaw tags. So this is a pretty simple technology. All we're doing is we're We're crimping on these metal tags with a specific ID number and releasing them, and then asking anglers to report these recaptures. And this way we can get some pretty simple data of where it was tagged, where it was recaptured, and the location, date, that kind of thing. Now this study was somewhat flawed, but they did find fairly low movement. And their general conclusion was that the overall smallmouth bass population may be comprised of numerous small stocks. So this is the concern where we might have localized overfishing, we might have loss of genetic connection, that kind of thing. But if you think about if we're asking anglers to do the recapture effort for us, people are not fishing evenly in space and time. People like to go fish where bass are concentrated. They're not going to go fish out in the middle of the lake. And also, seasonally in the wintertime and things like that, we lose out on a lot of data because people aren't fishing in January or February. I'm sure there are some folks, but most people are not. So that brings us to the present day, and we have some better technology on hand with which to investigate this issue. So Ohio Sea Grant funded this project, bought us about 100 or 210 tags or so, with which to tag smallmouth bass. And to get out this first fish personality question, we actually used two different capture methods. So we used angling to try and select for those high vulnerability fish. Of course, I'm not raising a whole population of numerous generations, but trying to get some high vulnerability fish. And then we're using electrofishing to not select for anything. This is kind of our control method where we're just capturing fish without selecting for a personality. Then when we go to tag them, we're not using jaw tags anymore. We're using acoustic transmitters. So we actually have to operate on the fish. This is kind of what it looks like, where we've got a special cooler with we can irrigate the fish's gills so it can breathe. We're delivering a mild electric shock so that it stays still. And then we're actually cutting open a slit in the fish's body cavity, sticking this transmitter in there, and then suturing it back up with surgical equipment. These transmitters are about the size and shape of a AA battery, and they emit an ultrasonic signal. In addition to the transmitter that's in the belly, we're also tagging them with external tags so that if an angler does catch one of these fish, hopefully they can read off the number on there and report back to us. So when we release this fish, it's swimming around in the lake and it's actually making sounds, but they're ultrasonic, you can't hear them, but sound in water travels pretty well. So we've got a range of up to a mile for these transmitters on a good weather day where there's not a lot of noise interference. So fish is swimming around, and that's only good if we actually put out something to listen for, like this acoustic receiver. So this is about the size and the shape of a 2-liter pop bottle, and it can actually record, it can pick up on these sounds and save a unique ID for each fish. So it'll say bass 1, 2, 3, 4 was at this receiver at this date and time. Now, one receiver in and of itself is not all that useful, but when we work together with researchers all across the Great Lakes, we end up with a map that looks like this, where each of these green circles represents one deployment of a receiver in the last 2 years or so. So Lake Erie has a pretty robust receiver grid. We've got something like 500 receivers out in the lake right now that are listening for these bass tags. And this is all through the international collaboration that we work under is called GLATOS, Great Lakes Acoustic Telemetry Observation System. There are 2 different points to be made here. While it looks like we have receivers everywhere and we get to see anywhere where a fish goes, Lake Erie is such a big lake that the space in between some of these receivers is on the magnitude of like 10 miles or 16 kilometers. So there's plenty of spaces for a bass to hide in here. The other question that I often get from anglers is, oh, where are your fish right now? I want to go catch them. Well, unfortunately, this is not live data. I can only tell you where my fish were a year ago. So in order to get the data off of most of these receivers, it's not live data. So we actually have to go physically grab them with a big grappling hook like this, pull them up, and then download them. Clean off all the zebra mussels, and then we typically replace the battery and redeploy them. So it's a fair amount of work. No one agency could do it, but we work with USGS, and a number of partners across the lake in order to share data and maintain this receiver network. So let's move on to what we've actually observed so far. So we were able to get all those tags out. So we tagged 96 fish captured via angling, and then 120 smallmouth bass tagged via electrofishing. And then for the results that I'm going to show you, I'm filtering out any fish that have not been detected on any of those receivers. So those could be dead fish, low movement fish. It's kind of hard to tell what exactly happened with them. But we have about 90 of each fish, or 90 fish in each treatment. As for tagging locations, we focus most of our tagging on our highest profile bass fisheries, which are the Bass Islands and Kelly's Island, over here in the Western Basin. But we wanted to also be able to compare between these different habitats that we have in Lake Erie. So we also tagged fish in Lorain, Fairport, and Ashtabula to get at some of these fish that don't have a lot of islands and reefs to hang out in. So I'm going to show you an animation that just shows all of these fish for the last year and a half. So each of these dots represents one fish that was tagged. And this is going to loop, so I'll let it play a couple times. Couple things to point out here. So we do see that most of our fish are not moving a whole lot. They're kind of sticking around in the same general area, especially these islands fish. And then some of these Central Basin fish over here are sticking around where they were tagged. Some of them are making movements, but they're typically nearshore movements. But we have observed a couple of interesting fish that make some pretty wild movements. Like there's one that was tagged here in Fairport Harbor that in August of 2023, in about a week and a half, it jets all the way across the lake and then comes back. There's another fish over here in the Western Basin that actually migrated into Lake St. Clair in each of the last 2 years during the early summer, and then migrates back into Lake Erie during the winter and the fall. So we're seeing some diverse movement patterns, but in general, fairly low movement. Fish are sticking to generally the area where they're tagged. When we go and plot that, just to get some initial results on the differences in fish personality. So here, what we're looking at is on the x-axis here. This is total distance moved over the course of either 6 months or a year and a half, depending on when the fish was tagged. This is just density of the data. So the higher the graph here, the more fish were observed with that total distance moved. And we're splitting by angling up here in red and electrofishing in blue. What we see is kind of what you'd expect. It's a right skewed distribution where the majority of fish in either treatment are not moving a whole lot. Relatively low movement throughout the course of the study thus far. However, we do see that there's a much longer tail on this red color. This is our angled fish here. And if you look at the central tendency of these data, we do indeed see that the median total distance moved for angling is about double that of an electrofished fish. Now, these are pretty preliminary data. These tags are good for 3 years, and we either have the majority of the fish, we only have 6 months of data collected. We can also break it down into months or seasonal activity. So we see kind of what we'd expect. In April, this is when they're the highest distance moved, or most movement on a daily basis. This is when they're moving to spawning locations. So we kind of expect to see high movement here. May and June are typically what are considered the spawning months. So we're seeing pretty low movement when they're sitting on nests. Increased movement through the fall into the winter, either potentially chasing bait or looking for overwintering spots. And then December, January, February, we're seeing pretty low movement, which is what we expect when the water temps are very low. So wrapping up here, what does this mean for management and how we can conserve this fishery? So we are seeing pretty low movement. That means that genetic connectivity might be relatively low. We might be catching the fish that are also making important genetic connections between subpopulations. We may see some localized overfishing, and tournament displacement may be more of an issue. Now, I should make the point that as of right now, I'm aware that I work for a management agency. We're not proposing to make any management actions right now. Harvest is very low for these fish. It's mostly catch and release, and we have a healthy fishery. So this is more of establishing a baseline and becoming aware of their movements. One management idea that we could consider is more popular in Canada. So in Ontario, they have some lakes with aquatic protected areas or sanctuaries where fishing just is prohibited throughout the year or prohibited during the spawning season. And this one interesting study from 2017 found that in areas where fishing was prohibited for 70 plus years, the bass that were spawning there had higher aggression and struck more times on lures than did fish in the same lake, but in areas that were not protected by a sanctuary. And as far as tournaments go, I really want to make the point that we are not considering stopping tournaments. We're not considering regulating tournaments. Tournament anglers are honestly some of our best partners in managing the fishery. I've worked with a number of tournament anglers and had a lot of great interactions. Tournament anglers tend to be the ones that are most passionate about conserving the resource, want to learn more about how we can protect this fishery and maintain a healthy smallmouth bass fishery for many years to come. So some of this is just about education, thinking about these kinds of things, talking with tournament anglers, which I do on a regular basis, and letting them know what we're seeing from this type of work. There are options for tournament managers. There's the possibility of catch, photo, release. That's more common in kayak tournaments where fish are not actually displaced. You just take pictures and then release them where you caught them. And then there's also a possibility of release boats where they take a big boat like this that has a huge live well, load up the displaced fish, and then drive them back out to something like what is their natural habitat. But of course, that has consequences for tournaments. This is expensive, and you have to have a special boat for it. These are just options that can be considered in order to kind of reduce the impacts of tournament displacement. So with that, that's all I have for now. I'd really like to thank the anglers that have helped me get fish tagged. Jeremy, Jimmy, the Gallaghers, Justin, all helped me tag fish. I've had a talk to a number of anglers who have reported recaptures, which is awesome. I love talking to folks, and it's really important data for me to have to know that the fish is alive and where it was recaptured. Ohio Bass Federation, Ohio Sea Grant, staff from the Division of Wildlife, from USGS, and from GLADOS. And then Sportfish Restoration is your taxed hours at work, paying our salaries to do this important work. In summary, some smallmouth can move a bit further than we once thought, but a lot of them are movement limited or they don't like to move. The high vulnerability fish may move more, but we do have management options. And again, I'd like to make the point that this study is really in its infancy. We've still got another 3 years or so of data collection that will happen, and we're going to learn a lot more about large or smallmouth bass movement with the coming years. So thanks a lot. I really appreciate everyone's time, and I guess I'll take questions if we have time.
All right. And we've gotten some good questions, so let me get right to them. I had a couple of questions that were clarifying questions, so let me do those first. One question was, in the animation that you had, is one point a single fish, or are those pings for multiple fish?
Each point represents one fish. Sometimes there's a little bit of doubling up, I think, here, but yeah, in general, each of these circles is one smallmouth bass.
Okay. And do you see like the larger, older smallmouth move more or less than younger fish?
So I haven't actually looked at that. I've only gotten the most recent. I get data downloads from GLADOS on a 6-month to a year basis, and I just got the most recent data download about 3 weeks ago. So I haven't crunched all the numbers. I don't know about older because we have not aged these fish, but in general, larger fish probably move more, just based on the scientific literature.
Okay. And would that be the same as, so another question was the movement difference between, say, males and females? Is that a part two to your research?
So we weren't able to sex the fish when we captured them. We had a lot of, I tried to do it, but we had a lot of difficulty. So I don't know that for sure. I can tell you that in general, um, we know from other species movements that that males tend to migrate first and arrive on spawning grounds first and hang out there for longer, and the females tend to show up later and hang out for less time. But yeah, we don't have an aspect of that in this project, unfortunately.
All right. Um, would there be factors that could potentially affect movement? Like, did you see any changes when, say, HABs occurred
So I
or
haven't
harmful
looked at
algal
that
blooms? Harmful
that
algal
yet.
blooms, sorry.
Yeah, harmful algal blooms and their relation to movement. So I haven't actually looked at that. That ideally I could superimpose that over an animation like this, but as of now, I would suspect that we wouldn't see a whole lot because typically we see we don't even have fish tag. Harmful algal blooms are normally over here towards Maumee Bay. We don't have a lot of fish tagged over there. And I'm not seeing a lot of movement patterns in the summertime that would indicate that they're responding to HABs or even like hypoxia in the Central Basin or something like that. But that is a possibility in the future. We can definitely look at that.
All right. Um, has is Oh, another question dealing with the fish movement. When you had the 2 or 3 fish that like went across the lake or went into the other lake, how much travel was that? Like, how long was that? What was the longest? The question was, what was the longest a fish traveled?
Oh yeah, I mean we can even look at this graph. So some of these fish are traveling 600 kilometers. So that's what, like, I don't know, 400, 450 miles in a year and a half. We've already seen from a pilot study that smallmouth bass can move over 300 miles in a year. So they are capable of making long distance movements. We just that pilot study didn't really establish whether they do that naturally. But we are seeing that they are capable of making moving hundreds of miles in a year. We just don't know that that's necessarily a common thing.
Um, Another question was dealing with, would drone technology be considered to collect movement data to possibly cover more areas of the lake?
Yeah, that's an interesting question. We haven't done a whole lot of that, but there is a group called Rayon that is out of let's see, Trent University, I think, that actually is working on they call them UAVs, underwater automated vehicles, and they actually have, so they look like submarines or like torpedoes that actually can be deployed and listen for tags and also sample water as they go through the lake. So we haven't done that much with the division, but that is a growing part of our technology suite.
All right. Um, Another question that we had was whether or not um, do the tags impact behavior?
That is a great question. We don't know that for sure because that's very hard to study because in order to study the movement, we have to tag them. So it's hard to not tag them and then study the movement. Um, we do things like we keep the tag burden low. Tag burden meaning like the proportion of the proportion of the tag's weight to the fish's weight is real low. It's 2% or less. We can also we can censor uh, the first month or something like that, and that's a pretty typical thing to just remove the first month, say this is our tagging effects, and anything after that is natural movements. But it is an assumption that we are making.
All right. Another question we got was, Do tournament fish get tagged before they're released? And do you know if they return to where they are caught? Would it be possible to take GPS where fish were caught during tournaments so that if they're tagged, you could track their movements after release?
Yes, that's a great question. So this tournament displacement, tournament release, return to capture sites has been fairly well studied in the bass research world. Unfortunately, the results from those studies are kind of all over the place. We don't understand all the factors that are involved in that. Some studies show that bass hang out around tournament release sites for months at a time. Some studies show that they are out of there within a week. The pilot study that I mentioned, we actually tagged 23 bass in a Ohio Bass Federation tournament in 2018 and looked at how quickly they disperse from Shelby Street Boat Ramp in Sandusky. And we found that all of the fish did leave the release site. It took them on average 2 weeks. And about 60% of our fish left Sandusky Bay and made it out into the main lake after 2 months or so. So unfortunately, we weren't able to confirm that they were making it back to their capture sites because of difficulties while we were tagging them. We kind of got overwhelmed by the number of fish coming in so quick. But it's certainly a possibility, and that's a thought for a future study for sure.
Um, I have two more questions because I'm noticing that it's past 12:30, so I don't want to have everybody be on too long past our time. One question that we had was if you could talk a little bit, and this would, in recognizing that this is not in the focus of your research, but would you be able to say anything about the movement of stream resident smallmouth bass and how it might differ from those of lake populations?
Yeah, so river and stream smallmouth bass movement has been studied a bit more than a large lake situation like this because it's just a little bit easier to do it because you don't have to put this huge grid of 500 receivers out. You can just put, 50 receivers or 100 receivers in the linear fashion like a river. As far as that is concerned, I want to say that most of those fish do not make long distance movements, but they do see that that some fish can make movements of 80 miles or more. They do see upstream movement during the spawn, and then downstream movement during fall and winter.
All right. Another question that we had was, and sorry, I just lost it. A clarifying question of, do smallmouth bass return to the same spawning area?
Yeah, so that is a question that we're going to look at. We haven't collected enough data yet. Most of the fish that we tagged last spring, so we don't even know that yet. But we know from the literature that yeah, they probably go back to the same areas to spawn each year.
Okay. And the last question that we had was, what do you feel are the long-term goals of this study? I had a couple of people ask, what's the next step
Mhm.
to this research? I know, knowing that you have a couple more years of data collection, but what do you feel is the next step, and what you're hoping the overall goals, what you will find out about this project with this
Mhm.
project?
So the overall goals, I mean, a lot of it is just establishing a baseline of understanding, scope of smallmouth bass movement, return to capture locations, just kind of baseline stuff like that, because this is really the first time that we've tagged smallmouth in one of these Great Lakes settings where they have unlimited areas to go almost. So establishing baseline, starting to understand, are we seeing some effects from angling, or is angling catching the fish that are making long distance movements, that kind of thing. As far as next steps, there's so many different questions that we could ask of just these data. We can do an analysis looking at size of fish. We can look at HAB influence, or or dissolved hypoxic areas, that kind of thing. Um, there's a lot of different things that we can do with just this data set that's going to come out. And also look at like habitat associations, that kind of thing. As far as next steps, that we could look at a much bigger tournament displacement study, look at whether fish make it back to the capture locations. And ideally, we'd like to do this at multiple different tournaments throughout the season, and in both western and central basins, to look at whether fish return to their capture locations, how long they're sitting at tournament weigh-in sites. And then another thing that we could look at is catch and release mortality, or effects of catch and release on this population. That's definitely a question in a lot of people's minds, including my own.
All right. Well, I think those were the majority of the questions that we had, and it looks like we're a little over time. So I will close here with a big thank you to Zach for his willingness to talk to us today about his research. This was really an excellent discussion. And Zach, I've already gotten people asking if you can come back when your research is fully done so you can do a part 2 to this.
Yes. I'd love to. And I know there's other questions that I haven't been able to answer. Please feel free to email me. My email's down here at the bottom. So
Oh, perfect. I was just about ready to say, so that's perfect. And I will make sure to also get your email into the email I send to everyone about the recording. So this is perfect. I also wanted to remind everyone that the survey URL is for this webinar is in the chat feature. So if you could take a few minutes to fill that out. This webinar series is sponsored by Ohio Sea Grant and will continue in December with Ohio State's Nick Basta, who will be discussing his research on water treatment residuals in soil. The registration link is in the chat. Thank you again, Zach. This was such a great webinar, so we really appreciate your time. Thank you to all the participants on this webinar. We hope this was beneficial, and we hope that you'll join us again in an upcoming webinar. Thank you again, Zach. Thank you, everyone, and have a great afternoon. Thanks, Zach.
thank you, Jill.
Truly appreciate it. Thank you.
Sure thing. Thanks for having me.
Absolutely.